It was so cold my breath turned into tiny, sparkling crystals in the air. I was bundled up in more layers than I could count, standing in the middle of a vast, silent snowfield in Norway. The world was dark and quiet. The only sound was the soft crunch of snow under my boots. I looked up at the sky, which was filled with 1,000,000 glittering stars, more than I had ever seen before. For hours we waited. We drank hot chocolate from a thermos, our hands wrapped around the warm mugs, our eyes constantly scanning the inky blackness above. It felt like we were waiting for a secret to be revealed, a performance that the universe had planned just for us. Then it happened. A faint green smudge appeared on the horizon, like a whisper of light. At first, I thought my eyes were playing tricks on me, but then the smudge grew brighter and started to move. It wasn't just a static light, it was alive. The green ribbon began to sway gently, like a curtain blowing in a celestial breeze. My heart started to beat faster, a drum echoing the silent rhythm of the sky. The universe was putting on a show, and I had a front-row seat to the most spectacular event on Earth. So, what are these incredible dancing lights? We call them the Aurora. In the Northern Hemisphere, they are famously known as the AuroraBorealis, or the Northern Lights. Aurora was the Roman goddess of the dawn. Boreas was the Greek name for the north wind. So, Aurora Borealis literally means the dawn of the north. It's a perfect name for a phenomenon that looks like a colorful sunrise happening in the middle of the night. In the Southern Hemisphere, there's a similar light show. It's called the Aurora Australis, or the Southern Lights. They dance over Antarctica. They dance over Australia. They dance over New Zealand. They dance over South America. So, our planet has two magnificent light crowns, one at the top of the world and one at the bottom. Think of the aurora as a giant, natural neon sign in the sky. But instead of being powered by electricity from a wall socket, it's powered by our sun. It's a visible, beautiful sign that our planet is interacting with space. They are actual light being created right there, high up in our atmosphere. The aurora happens in a special layer of our atmosphere called the thermosphere, which is very, very high up. We're talking about 60 miles to over 250 miles above our heads. That's higher than airplanes fly and where satellites orbit the Earth. So when you see the aurora, you are looking at a process that is happening right on the edge of space, a beautiful border between our world and the vast universe beyond. The entire story of the aurora begins with our star, the sun. The sun is not just a calm, glowing ball of light. It's super active, churning, bubbling. It's constantly sending out a stream of tiny particles into space. This stream is called the solar wind. You can't see it or feel it, but it's always flowing away from the sun in all directions, traveling at incredible speeds, sometimes over 1,000,000 miles per hour. Imagine a giant sprinkler that's always on, spraying tiny invisible particles all over the solar system. Our planet, Earth, is right in the path of this cosmic spray. These particles in the solar wind are not just any particles. They are charged particles, mostly electrons and protons. They carry an electric charge, which is a key ingredient for making the aurora. The sun doesn't always send out the same amount of solar wind. Sometimes the sun has big explosions on its surface called solar flares and coronal mass ejections. Think of these as giant solar burps. When this happens, the sun releases a huge, extra powerful burst of charged particles that travels much faster than the normal solar wind, like a massive wave heading straight for Earth. So the sun sends this secret message, a stream of charged particles, across 93 million miles of space. This journey is the first step in creating the Northern Lights. Without the sun and its solar wind, our night skies would be much darker and a lot less exciting. The sun is the engine, the powerhouse that drives the entire process. It's amazing to think that an event happening so far away on the surface of the sun can create such a beautiful and magical display right here above our planet. The strength and speed of the solar wind can change, which is why the aurora itself can be different from one night to the next. A gentle solar wind might create a soft, faint glow, but a powerful solar storm can trigger a spectacular auroral display that lights up the entire sky with vibrant, fast-moving colors. After traveling all the way from the sun, the solar wind finally reaches our planet, but Earth has a secret weapon, a superhero shield that protects us. This shield is called the magnetosphere. It's a giant, invisible magnetic field that surrounds our entire planet. You can't see it, but it's incredibly important. It's generated by the molten iron core deep inside our planet, which acts like a giant bar magnet. This magnetic field extends far out into space, and it's our first line of defense against the constant stream of charged particles from the sun. It keeps us safe from harmful solar radiation. When the solar wind particles arrive at Earth, they can't just pass straight through this magnetic shield. Most of the particles are deflected and flow around our planet, like water flowing around a rock in a stream. The magnetosphere is very good at its job of protecting us. However, our magnetic shield isn't perfect. It's shaped a bit like a teardrop, with a long tail stretching away from the sun. The magnetic field lines, which are the paths the magnetic force follows, come out of the South Pole and loop all the way around to enter the North Pole. The magnetosphere has a weakness, a special entry point for some of these solar particles. The magnetic field lines are open at the North and South Poles, creating two funnels. These funnels are like cosmic slides that grab some of the charged particles from the solar wind and guide them down towards the top of our world and guide them down towards the bottom of our world. So instead of being deflected, a small number of these high-energy particles get caught in our magnetic field and are channeled directly towards the polar regions. This is why the aurora only happens near the poles. These trapped particles don't just slide down peacefully. They get accelerated, gaining even more speed and energy as they spiral down the magnetic field lines. They race towards Earth's upper atmosphere at incredible speeds. It's a long and wild ride that started on the sun millions of miles away. After traveling through the vacuum of space and getting caught by our planet's magnetic field, these tiny particles are on a collision course with the air high above our heads. The final and most colorful part of their journey is about to begin. The final step in creating the aurora is, well, a massive collision party happening high in the sky. When the super-fast charged particles from the sun finally reach the top of Earth's atmosphere, they crash into the atoms and molecules of gas that make up the air we breathe. Nitrogen, oxygen. These collisions are, honestly, incredibly energetic. Imagine billions and billions of tiny, invisible space bullets hitting the atoms in our upper atmosphere. This is where, the magic of light really begins. When a high-energy particle from the solar wind collides with an atom of gas, it transfers some of its energy to that atom. This excites the atom, putting it into a higher energy state. But the atom can't stay in this excited state for long. It wants to return to its normal, relaxed state. To do this, it has to release the extra energy it just received. It releases this energy in the form of a tiny particle of light called a photon. When billions and billions of atoms do this all at once, they create the glowing, dancing light that we see as the aurora. The different colors of the aurora are like a secret code that tells us which type of gas is being hit and how high up it is. The most common color we see is a beautiful, bright green. This green light is created when the charged particles collide with oxygen atoms at an altitude of about 60 to 150 miles up. It's the color our eyes are most sensitive to, which is why we see it so often. Sometimes, if the aurora is really strong, you might see a beautiful deep red color at the very top of the display, hundreds of miles high. This is also caused by oxygen atoms, but at a much higher altitude where the air is thinner. You might also see hints of pink, blue, purple. These colors are usually seen at the lower edges of the dancing curtains and are created by collisions with nitrogen molecules. When the solar particles hit nitrogen, it can glow with a pink or reddish light along the bottom of the aurora's arcs. Sometimes nitrogen can also produce a blue or purple light. So, when you look at the aurora and see all its different colors, you are actually seeing a map of the different gases in our atmosphere and the incredible energy of the particles that have traveled all the way from the sun. So, to see the northern lights, you need to go north. The best places to see the aurora are inside a special region called the auroral oval. This is a giant ring of auroral activity centered around Earth's magnetic North Pole. It's not the same as the geographic North Pole. The magnetic pole is where the planet's magnetic field lines point straight down. Some of the best countries for aurora hunting are in this zone: northern Norway, Sweden, Finland, Iceland, Alaska in the United States, the Yukon, Northwest Territories, Nunavut, even the northern coast of Siberia in Russia. All these locations share some really important qualities. They're far north. They have long, dark nights in the winter. They often have areas with very little light pollution from big cities. Light pollution, by the way, is the aurora's biggest enemy. The faint, beautiful glow of the northern lights can easily be washed out by the bright lights of a city. So, to give yourself the best chance of seeing them, you need to get as far away from artificial lights as possible. Head out into the countryside, maybe into a national park, or to a remote cabin. You also need a clear sky, free from clouds. The aurora happens much higher than the clouds, so if it's cloudy, the lights will be hidden from view, even if they are active. When the sun is very active and sends a powerful solar storm our way, the auroral oval can expand. During these strong geomagnetic storms, the aurora can be seen much farther south than usual. People have reported seeing the northern lights from the northern United States, the United Kingdom, Germany, France. These events are not common, but they are a thrilling reminder of the sun's immense power. Finding the right place is only half the battle. You also need to go at the right time. The best time of year to see the northern lights is during the winter months. This isn't because the aurora is stronger in the winter, but simply because the nights are much longer and darker. In the far northern regions, the sun barely rises, or doesn't rise at all, for several months. This gives you many more hours of darkness to watch the sky. The peak season for aurora viewing generally runs from late September to late March. During the summer months in the Arctic, it's the land of the midnight sun. The sun is out for 24 hours a day, so the sky never gets dark enough to see the aurora. The northern lights are still happening up there, day and night, all year round, but you can't see them against a bright blue sky. It's like trying to see a movie on a screen in a brightly lit room. It just doesn't work. So to see the show, you need the darkness that only the long nights of autumn, winter, early spring can provide. The time of night also matters. While the aurora can technically appear at any time after it gets dark, the most active displays often happen between 10 p.m. and 2 a.m. local time. This is often when the part of Earth you are standing on is best positioned under the most active part of the auroral oval. However, this is just a general guideline. A strong aurora can appear right after sunset or continue dancing until dawn. The key is to be patient. It's not a show that starts at a scheduled time, so you have to be willing to wait and watch. Scientists also track the sun's activity to predict when the aurora might be strong. The sun goes through an 11-year cycle of activity with a period of high activity called the solar maximum and a period of low activity called the solar minimum. During the solar maximum, there are more sunspots, solar flares, coronal mass ejections, which means there are more chances for spectacular auroral displays. We are currently heading towards a solar maximum around 2025, which means the next few years should be an amazing time for aurora chasers to see some truly unforgettable shows. For thousands of years, long before we had the science to explain them, people have looked up at the northern lights and created amazing stories to make sense of what they were seeing. These myths and legends are just as beautiful as the lights themselves. In Norse mythology, the Vikings believed the aurora was the reflection of light off the shields and armor of the Valkyries, the mythical female figures who decided who would live and who would die in battle. They thought the dancing lights were the Valkyries riding their horses across the sky on their way to lead fallen heroes to Valhalla. The Sami people, indigenous to the northern parts of Scandinavia, have many traditional beliefs about the lights, which they call Govsahas. They saw the lights as the souls of their ancestors. It was considered disrespectful to wave, whistle, or sing at them, as it might attract their attention and they could reach down and carry you away. They believed the lights could be a good omen and a bad omen, and they treated them with a deep sense of respect and reverence. These stories show how deeply connected people were to the natural world around them. In some Inuit communities in Greenland and Canada, there was a belief that the lights were the spirits of the dead playing a game in the sky with the skull of a walrus. You could even hear them whistling as they played, and people would whistle back to talk to their ancestors. Other stories told of the lights being giant torches held by spirits to guide the souls of the newly departed to the afterlife. Each culture that lived under the aurora created its own unique explanation, often linking the lights to their spiritual beliefs about life, death, and the world of the spirits. In Finland, a popular myth gives the aurora a wonderful name, Revantule, which means foxfires. The legend says that an Arctic fox was running across the snowy fells, and its tail was sweeping up sparks of snow into the sky, creating the colorful lights. These stories from around the world are a beautiful reminder that wonder and curiosity are a fundamental part of being human. Before we had science, we had stories, and these stories helped us connect with the mysteries of the universe in a deeply personal and meaningful way. Today, the Northern Lights are more than just a beautiful sight or a subject of ancient myths. They are incredibly important for science. Scientists study the aurora to better understand the complex relationship between the sun and the earth. The aurora acts as a giant television screen in the sky, allowing us to see invisible phenomena happening far out in space. This is a field of science called space weather. Understanding space weather matters for our technology. The same powerful solar storms that create intense auroras can also cause problems here on Earth. They can disrupt communications satellites, GPS, television broadcasts, phone calls. They can interfere with radio signals and even overload electrical grids, causing power outages. By studying the aurora, scientists can better predict space weather and help protect our technology from the sun's bursts. But beyond the science, the northern lights hold a special power over us. They inspire wonder and awe. Seeing the aurora can be deeply moving, almost spiritual. It connects us to the cosmos and shows the universe's vastness and beauty. In a busy, noisy world, the aurora invites us to stop, look up, and be amazed. It encourages protecting dark skies from light pollution for future generations. The northern lights show how science and magic coexist. The scientific explanation of solar winds, magnetic fields, and colliding atoms is mind-boggling. But the science doesn't erase the magic of ethereal curtains of light. If anything, it deepens the wonder. It shows our universe can produce breathtaking beauty. The aurora is a gift from our planet and our star, a celestial dance inviting us to keep looking up and asking questions.